In this video, I'll be introducing a simple new adapter that allows you to use standard torque wrenches, such as this, with your Lee Classic turret press. Before I get into the installation of the adapter, let's talk a little bit about the different types of torque wrenches. This is a 3/8 inch drive torque wrench, so if I use this, I have to use a 1/2 inch adapter. You actually read the force directly off of the scale. And the nice thing about this type of wrench as opposed to the clicker type, you don't have to reset for different forces, for different applications or different cartridges. This is the torque wrench I use most often. It has a wide range. It has an interchangeable head, and it can adjust by 1 foot-pound increments anywhere from 5 to 70 inch-pounds. So this is an excellent torque wrench to use. You do have to adjust it for the different applications, and it is the clicker style. When you hit the force that you want, the torque wrench clicks, so you know that you've applied the proper amount of force. This is a larger torque wrench that many people may have. It's a ratchet style torque wrench. This also works. This particular torque wrench goes as low as 20 foot-pounds. Let's go ahead and jump into the installation of the adapter. The adapter can be set up for either right-hand or left-hand operation and is intended to be installed permanently. I'll be demonstrating left-hand installation for the ease of videoing the installation here. To start, you loosen the 5/16 inch bolt that is used to hold the lever clamp, and it's quite easy. You loosen the bolt here, okay, and you can see, I'll take the bolt completely out so you can see the bolt that I'm talking about. Okay, I'm going to put it back in so that the clamp assembly does not go away, so you want to loosen that so that the lever comes free of the clamp assembly. You slide the lever out of the clamp assembly, and then you want to orient the adapter. You can see there's 2 holes on the adapter. This hole has a square shape that accepts the drive from the torque wrench. There's another hole that the lever goes through. Now, if it's on the left-hand side, you want to orient the square drive hole to the left so that the torque wrench can be inserted into it. If it's on the right-hand side, you would orient it in the other direction. So for right-hand assembly, the square hole will face to the right. Once you've oriented it properly, you will slide the lever through the 5/8 inch hole. You can see how easily it goes on. You then reinsert the lever into the drive clamp, into the lever clamp, making sure that the lever protrudes fully through the clamp, and then you can tighten the 5/16 inch bolt so that the lever is clamped solidly into your press. Okay, now you can see that the adapter will slide on the lever. So to prevent it from sliding, you take a 1/8 inch hex key, and there's a set screw that you can tighten here. You can, as always, adjust the position of the lever to your preference. But with this, the adapter is completely installed, and as you can see, it's as simple as taking your torque wrench and inserting it into the adapter, and now you've got your lever and torque wrench installed into the adapter. So it's that simple. You can see here with the 3/8 inch torque wrench, you install the adapter, and again, and you can position the torque wrench lever in any position you want, whatever's convenient for the operation you're doing. And with the ratchet style torque wrench, of course, you can install it and you can position the lever using the ratchet, and so that's pretty much it. And you can see the levers move together and you can apply the torque as needed. So now that we've showed installation of the adapter onto the lever handle, I want to show the option of replacing the lever completely. So first I'll start by removing the adapter. So I'm going to loosen the set screw. Okay. Loosen the 5/16 inch clamp bolt so that the lever can slide free. And to replace the lever completely, you're going to need either a 5/16 inch bolt. I kind of like using the 5/16 inch bolt because I can put a nut on the end. But you know, if you have a length of 5/8 inch tubing that you can use in place of the lever handle, you can use that as well. So with the lever out, take the nut off. You can install the bolt through the clamp assembly and tighten the lever clamp as before, with the square hole oriented in the proper direction. Slide it over the bolt. You can optionally put a nut on top of it and tighten the set screw. And with that, the adapter is installed. You can see there's no lever. Use of a ratchet style torque wrench is not suitable if you remove the lever. You're going to want to use either the beam style torque wrench, or in my case, I like using this direct drive with no ratchet on this torque wrench. And you install the torque wrench on here, and as with the lever, you can, using the clamp assembly, position this in any orientation that you like that's most suitable for you. Okay, so that's how you replace the lever completely. Let's talk a little bit about some of the operations and the benefits of using a torque wrench for those operations. Let me start with collet neck sizing. If you have a Lee collet neck sizing die, and you follow Lee's directions for installation of this die, you'll know that they don't actually want you to cycle the die fully through your press. You're supposed to apply the right amount of force, and then you're supposed to apply that same amount of force every time you do it. And frankly, there's no way to do that without something like a torque wrench. So this is one of the best applications for using a torque wrench on your press. Using a torque wrench and controlling the force has a number of benefits. One, you can repeatedly apply the same amount of force and get the same results time after time after time. Without that, I don't know how you do that unless you're just a robot. Anyway, the other benefit is reducing the forces, reducing the chance of accidentally applying excessive forces to the die that increases the wear. So let's talk a little bit about that. Let me take this apart so that you can see how it works. Okay. The die is made up of just a few parts. The key parts are the body, of course, with the cap. But there's this, there's the collet. Let me set that down. And then there's a forcing cone and a mandrel. Okay. The way this works is that, let me get a little closer. The collet has slots in it. Okay, hope you can see that. That create these 4 leaves. Okay, and these 4 leaves get forced into a forcing cone. If you can see this, this has a tapered shape to it. So when you cycle your press, it pushes on the bottom of the collet, forces it into the forcing cone, which squeezes these leaves together, and the mandrel creates the inside diameter, and these leaves apply pressure on the brass and do the resizing. I don't know if you can see, but there's a shiny, you can see with the shine, there's a ring that forms where the surface of the forcing cone and the collet meet and push together. Okay? That area wears over time. Now I'd actually suggest that you put some lithium grease or other type of lubricant to reduce the wear on these, on both surfaces. But using excessive force also wears this down over time and ruins your die. The other thing is, of course, that sometimes, I don't know if you've already used this, you've probably experienced this, these will stick. So by applying a constant force, and only the force necessary, you will reduce the wear and tear and extend the life of your dies. So that's an additional benefit on top of the benefit of getting consistent results in the resizing of your brass. Priming is a good application where controlling the applied force can have benefits. Using a controlled force when inserting the primers can reduce or eliminate some of the common problems that can occur during primer insertion, such as crushed or flattened primers. Those are the reason for that is excessive force applied during the priming operation, or the primers not being completely inserted due to not using enough force. This picture shows an example of a 9mm cartridge with a small pistol primer that's not fully seated. I used 15 foot-pounds of force to get this result. This is another example of a 9mm cartridge where the primer was properly inserted. You'll notice that the primer is not crushed or flattened, and 20 foot-pounds of force was used to get this result. This final example is another picture of a 9mm cartridge where the primer was inserted with excessive force. You may be able to notice that the primer sits lower in the pocket and that the top of it was flattened. As I stated before, I used a used primer because I didn't want to apply excessive force to a good primer for fear that it would go off. Finally, the last operation I'll talk about where controlling the amount of force can show benefits is in the crimping operation of your bullets. As with collet neck sizing, if you use a collet style crimping die, the setup would be very similar, where you do not want to completely cycle the die. You want to apply a certain amount of force, and the only way to control that force is with something like a torque wrench. And again, the benefits would be repeatable results time after time. You want to control the amount of force because you can actually deform the bullet during the crimping operation. Now, just so that I can show and demonstrate, I applied excessive force to another bullet, and hopefully you can see a very significant deformation of the bullet. That's something certainly you would want to avoid. So crimping your bullets. Another good application for controlling the force.